participants, they are from, let's say, like the developed nations, right? So the Western Europes or big countries like Brazil, Mexico, that we seldom see, for example, people from our part of the world here in Southeast Asia, from Indonesia or from Singapore even. There is no much participation in that sense. And we try to understand the reason behind and realize that there are two big problems faced by students who want to join RoboCup at home. So the first problem is, as you can see, it's a very difficult competition, right? So it can, not only students need to have a solid foundation in engineering, okay? So that is, sorry, sorry. Did I share the screen? I'm sharing my screen, right? Okay, yes. Okay, yes. So so first of all, the main challenge that faced by them is that it's very difficult because it's actually involved engineering, so building the robots from scratch, but as well as the whole computer science, right? Programming, writing algorithms to control the robot, and that's actually computer science. So these are actually very big areas that are transcending the usual, let's say, engineering curriculum, even at the university level. Okay, so that's the first step. It's highly complex. The second is a very practical problem that is actually very expensive to build a robot like this from scratch. So if you take this blue color robot or humanoid as example, it can cost anywhere from tens up to hundreds of thousands of US dollars just to build the robot, because they are using very expensive sensors and equipment that makes the whole thing very challenging or very expensive, right? And it's really unaffordable for many students or schools or university around the world, okay? So that prompted us to ask ourselves, can we do something about this, right? So how can we help more schools and more university, more academic institutions to join RoboCup at home or to actually to start learning AI and robotics, okay? So the other observation that we made is on the robotics, on the current robotics education. So usually, I'm sure that you have seen or familiar with this type of, let's say, like line tracking robotics competition, right? And it is, I think, it's very widely spread, whether in Indonesia, Singapore, USA, anywhere around the world, right? So we've seen school children joining such robotics competitions years after years. And to be honest, the nature of the competition, in our opinion, is that it doesn't really change much in the last 10 years or so. Whereas the world is in a very different place now, right? Nowadays, we talk about autonomous vehicles, Internet of Things, or even like driverless car, right? So like an autonomous vehicle that doesn't even need a driver. So let alone need to follow a line, like what we ask our students to do, right? They need to make a robot to move along this line. So my collaborator at the university made this observation that students who claim they've gone through robotics education, they are facing enormous challenge when they are wanting to start a robotics career at the tertiary level, right? Because at the university, professors usually have different expectations of what the students should come up with when it comes to robotics. That the robotics solution should be able to solve everyday's problem, like, I don't know, like traffic in Jakarta, right? So these are very different situation compared to what we are training our students for. So as such, we think that there's a different approach being used here. The traditional robotics education, I think it is good as a fundamental basic training, but it's very much based on a conceptual environment, right? So you have a whiteboard with a black line, and students need to make the robot to follow the line. But this is by no means the reality, right? I mean, the reality, as I say, in the streets of Jakarta is chaotic. There are many cars. There are many unknowns. That is unpredictable. So as such, we think that there is a breaching problem that we need to address here, so that we can better prepare our students to come up with something that is useful, that is usable later, okay, when they graduate from university or even when they join a company, right? So you need to come up with a robotic solution that can be used to solve everyday's problem. So as such, we want to address this gap by really exposing students to AI and robotics applications in a practical manner, okay? So come back to RoboCup at home. So you actually join RoboCup at home education. So that's actually the purpose of education, is that we want to go back to basics and enable more students to start learning AI and robotics, and not just to stay at the usual Lego types of robotics. Okay, so first of all, they encourage students who wants to build robots. They can build robots. In fact, if you use a lot of open robot platforms, you can actually save a lot of costs, right? Because you can use open robot platform, open source software that can reduce the cost of participation significantly. In fact, this is how we eventually came up with our products. Although building robot is actually not as easy as it sounds. So I will explain it a little bit more later. But the idea here is that you don't need to have hundreds of thousands of dollars just to get started like the traditional RoboCup at home. That's actually a more affordable way, okay? And with RoboCup events or the network, there has been the whole range of activities or challenges. So the last international challenge or RoboCup at home education challenge physically was in Sydney 2019. Of course, last year and even this year was due to the pandemic. It was held online, right? So I'm not sure whether did you follow the finals like 2 weeks ago. Yes, so it was held online, but it is nevertheless a very important element to consider as well. That if you want to like start this initiative in Indonesia, so there's an opportunity to send your students to join worldwide competitions, or even better is that eventually one day we are able to host this competition in Surabaya, right, in Jakarta, in Indonesia level for the students there. Once you want to lead this locally for Indonesia, okay, and we as a company, we support academic institutions, schools like yours who wants to deploy this initiative to join competitions or just as a usual training, right? As a usual robotics trainings for your students. Okay. So I'm not sure whether did I share the YouTube video of our product, Jupiter Robot. But let me tell you a bit of the background. So as we build robot, or as we encourage students to build robot, we realize that one of the biggest problems, if you want to DIY robot, your own robot, is that you need to deal with the whole range of robotics equipments. So it could be like robotics arm, camera, navigation platform, and it is quite a time-consuming effort to integrate everything together from the hardware perspective, right? If you do not have that kind of background, it could be quite a painful process until you get everything right, because you're dealing with different manufacturers, different systems. That's not actually easy to get started, right? To build a functional service robots. Okay. So we have done that. We've done that over 10 years. That we thought that maybe I can support you by sharing this what we call now as a Jupyter robot, which is a development platform. So that if you have students that want to be involved in this, they do not need to buy the parts separately. That you can concentrate on learning how to program a robot. Okay, instead of spending time taking screwdriver to put everything together, we have done that for you, and that's the purpose behind Jupyter robot. So I said it's an integrated AI learning platform that has included the different modules. So starting from robotics arm, so which is the learning of object manipulation. So how you program the robot to carry a cup of water. And what about the second one is about the movement, right? So where robot can move from point A to point B using a process called simultaneous localization and mapping. And this is a process where a robot will use the camera system to identify its location, the location of the walls and the obstacle, and then it can then move with this map from point A to point B autonomously. By the way, this is the very same technology behind the driverless car. So this is already there in everyday's life, and we want students to learn about this. Okay, and then what do we have? Some more. The module of course deals with image processing, or the applications would be like, for example, face recognition. Nowadays we see that in the surveillance systems or even hotel check-in, airport check-in, the robot can actually identify a human just by scanning the face, right? So how does it work? And we want students to understand the principle behind. And probably a bit more than to understand is that we want them to design, to develop new products using face recognition. And we want to provide them the platform to begin with. Okay, and that is the Jupyter robot. And one last module is, of course, what deals with the natural language processing. So whether it's text to speech or speech to text, nowadays we can talk to robot, right? I think you can even talk to robot in Bahasa in Indonesia. So there must be some software out there, whether for English, German, Indonesian. There are open source software that we want students to learn how to communicate with a robot. And as such, we provide this platform so that you can get started in learning all these different technologies. Okay, all right. So, as I said, the Jupyter robot as our product is an integrated AI robotics platform that is ROS-based, so based on robot operating systems in Linux, so in Ubuntu Linux systems, and it is an open platform. So, open platform is a very important characteristic. Most of the robots that you can find out there is usually a closed proprietary systems, right? That whatever you learn is what the manufacturer intended for you to do. But we don't believe in that. We are just a very small company in Singapore and China that we thought that we want to enable you or enable your students to learn from the worldwide open source community, that you are not constrained to any particular brand or any particular systems apart from the Jupyter robot learning system, which is just a framework to put everything together. But you are free to modify the robot, you are free to port your development from one system to this system and vice versa. And what students need to know is actually one thing, and that is programming or coding. We recommend Python, but you could start with C++, MATLAB, etc. But that's the only requirement. It doesn't matter how old your students are. It doesn't matter whether your students are engineering students or computer science students or high school students or university students. What really matters, as long as they have the basics in programming, ideally Python, then you can get started. So as I said, the Jupyter robot is something that is already ready, integrated the 4 different modules. Navigation, so that is the movement with the base. And then we have computer vision, so that's using camera systems, so how the robot can see. And then the robot can grab objects using the robotics arm. And of course, you can listen and understand languages using speech recognition and synthesis technology. And we do have a computer here on board. So we are not using any Raspberry Pi or any microcontroller because we need the robot to be able to do generally the robot sensing and control. And if you are into machine learning and cloud computing, you can connect this to an external GPU for that kind of activities as well. But this itself is a complete integrated AI robotics platform that I thought to introduce to you here, that you can consider as a teaching equipment for your students in a laboratory setting, for example. Okay. And we have a second product, which is called Jupyter IO, that is actually developed very much thanks to the pandemic. So let me just play this video. So there's still someone, so let me admit him or her first. So this Tego. Okay, all right, hi Tego. So let me continue. Yes, so last year, due to the pandemic, we understood something, is that sometimes the universities is closed, the schools is closed because due to the lockdown situation, right? A student cannot get access to the campus. So even if you have a robot, then it will be very hard for them to get started in the learning, right? If the robot is not with them. So as such, we thought that actually you can do a lot of learning even without having the full set of robot. So as such, we developed our second product, which is called a Jupyter IO. And we can explain this understand this as a personal AI learning box that is for individual learning, right? So for all students, that they can learn it without the need to share the robot with another colleague, right? So that's also, of course, some cost and consideration here that probably you cannot afford to give the Jupyter robot to each of the students, but probably you can afford to give a small unit like this for a class of 30 students, 20 students, for example, that they don't need to share, that they can get started to learn the basic modules, that is the speech and vision, exactly the same like the Jupyter robot. But of course, this is not a robot, then it cannot move, there's no robotics arm, and for that we have substituted them with a simulator. Okay, so in short, there's another important things I want to mention here as well. With Jupyter IO, we want to enable students to get access to the development environment in Ubuntu and ROS without the need to install any software. That you can just use the USB connection to plug into your PC or your laptop, any laptop. Like you can get the array boot into the Ubuntu and ROS without the need for software installation. Okay, so I think this is a very distinct advantage, because if you have tried to do it yourself, then you will know that it's actually not the most convenient thing to run the development in ROS and Ubuntu with your home computer, for example. Okay, so that's our second product, which is intended for as an individual AI learning process. Okay, so yes, we get to know each other through RoboCup at Home Education, and in fact, when we used to support them when they were still physical competition, and I think the last one in our region is in Kuala Lumpur in Malaysia in 2019. So first and foremost, as you can see from this picture, the robots come in different shapes and forms, right? So in fact, you do not need to buy the robot from us if you have already the robotics platform to join RoboCup and Home Education. So they themselves are a non-profit organization, right? You can join with any robots. But what we see is that there's increasing number of faculties in computer science or computing that they may not have any robots, right? And it's just more cost effective and time efficient for them to invest in 1 or 2 units of Jupyter robot from us so that they can get started in learning AI applications. So without the need to to go through the hardware integration phase. Okay, so come back to this event. So when it's a physical event, it's about 2 to 3 days, a combination of workshops, and we let the students to develop solution for the tasks. And what are the tasks? So the tasks are like everyday scenario, like what you say is very real life. So you need to make the robot to follow you to walk around, or you need to make a robot to help you carry the bag from the kitchen to the living room, or to identify whether someone is wearing a mask or not. So these are like everyday problems that we want students to think, how can they solve with AI robotics? And in fact, this is something that you can replicate in Surabaya, in Indonesia, once you started the local communities. Okay, so probably okay. I don't know about the age group of your students, but actually, so if you are thinking whether are you dealing with primary school, high schools, or even university students. But for us, we actually started our initiative first in mainland China for the RoboCup China Junior event. So I just play this video as well, a very short one, so they can see how we actually started off with commercializing our Jupyter robot first for RoboCup China Junior. Yeah. Okay, I just can short here. So I say, whatever they have told you so far is actually currently being attempted to teach high school students. So these are like 16, 17 years old from China that they already started to learn AI robotics. Of course, it's not easy, right? Because you need to learn coding before, and there's a lot of things to learn. But I think that is the trend, and that is the development nowadays that I want to bring, also impressed me so much that I want to bring it out of China to the rest of the world, right? So just to show you a bit of the possibilities, right? So that why we should move away from the standard robotics challenges that we can also consider using AI as a challenge. Okay. So concretely, what we provide as a company. So first and foremost is yes, of course, the robotics platform, the robot.io, and we can provide training workshop as well for your teachers, for your lecturers, for your instructors, for anyone that are interested to have an introduction of this. We can provide, let's say, like, so it used to be a physical training where we'll go to Surabaya to conduct a class training. Of course, currently due to the pandemic, probably it's not that easy. But we have brought everything online as well. So we ship the robot to the customers, and then we can do the virtual training online. Okay, and this could be anywhere from 2 days up to a week. Basically, depends on the profile of the participants. Okay, and if you are interested into this, into deploying this at your school, we can also help with creating the whole learning system, right? Including like learning portal. How do you how students start the learning process, and how to assess them, how to grade them, and the whole online package that is possible. And then working with RoboCup and Home Education, we made a source code repository and GitHub that you can also use it for assignment, examples, for the tasks that you give your students. Okay, so in terms of customers, so I say we actually started the whole initiative in mainland China for high schools over there, and so these are like high schools in mainland China that deploy Jupyter Robot Learning Solution, and I'm myself based in Singapore, responsible for the whole world. So there's so in our region here in Malaysia, so there are 2 universities, Australia, high school, but we even exported very far away in Mexico, Slovakia, USA, etc. Okay. So a few final slides of what needs to be learned, right? So first and foremost, ROS. So robot operating system. So that is the standard framework for robotics research and development nowadays. The students need to know at least a few key concepts of ROS, publisher, subscriber, so that they can do the development. Okay. And then we straight away go into the different modules. So speech interaction. So what is speech synthesis, and how to recognize speech online or using offline method. And what for computer vision, so how do robots see humans? So how do you build a point cloud system? How does it recognize color, track objects? And then using camera system as well for navigation. So that is like what we mentioned just now about building the maps, and then for autonomous navigation. And one last module is the robotics arm that you build, that you use it for forward and reverse kinematic, and how you do the calculations. And most important of all is how you put everything together. Right? After learning all these modules, we are examples trigger tracking robot that can follow you around, or a punch robot, right? A robot that can invite, or they can detect guests and invite him or drink. So these are everyday scenario that we have examples that students can learn. But of course, we encourage students to modify the example, or even better, create your own. Okay. So I come to the final slide of my presentation. We haven't really spoken about this, but I just thought that yes, we met at the RoboCup Home Education. I think there are a few possibilities, right, of what you can deploy Jupyter Robot solution for. I think first and foremost, we want to promote education. So whether it's through formal school, formal universities, or private school, any type of that you are thinking about how you educate students on robotics, that we want to support you by providing this alternative, or probably not alternative, enhance the teaching with artificial intelligence applications for service robotics. It could be for high schools, or even for university, diploma, or even PhD level as well. So for anyone, any students, we want to enable teachers to have a platform so that you can start classes on AI robotics education. and training. So that is for another group of people that is probably not students, but they are equally interested in learning how AI robotics works. So they could be like engineers, professionals, scientists. So this could be a new business model. If I don't know whether your academy is doing this, but for the general public, right, training for general public. Research, so that's more for the schools. If they have any projects or thesis or final year project students that are in this area, then of course they can modify for this purpose. And last but not least, yes, of course, actually the one that's most relevant probably now is that yes, you can use this to join RoboCup Home Education Challenges. I said this year was just past. This year's competition was just over 2 weeks ago, online version. But for future, you can of course sign your students to join using the robot. And of course, we will be glad if you think that you have enough students that you want to do this in Indonesia. I think that's possible. In fact, I think there's RoboCup Indonesia as well, but we just need to do the alignment, and then probably you can take a lead in Surabaya to bring this for your schools, for your city, for other interested schools that you can organize this competition locally, and we'll be happy to see how we can support as well. Okay, I think in a nutshell, we want to enable everyone to start learning AI in a practical manner using robotics. Okay, Yudi, and all the colleagues here. This is my presentation for today. Any questions or comment?
Okay, Jerry, thanks for your presentation.
Yeah.
We plan to start a competition like this. Maybe if we can help RoboCup at Home Education Indonesia, we will help at January 2022.
Oh, okay, okay, okay. But can you tell me a bit of the background of the students? So, so these are how to say? Do they come to you full time students, or what kind of courses are they doing at your academy?
I running to activity in my academy in uh, my place, and um, other place is running by other person, but they usually follow my competition, and I will ask them to join to learn AI together, such as I asked to Rizky, Mr. Teguh, and other to join this meeting to give them uh, the robot lookalikes
Yeah.
for they learn more about AI robotics.
Yes.
Maybe I will um, invite you to the competition that we will held in January.
Yeah, yeah, yeah. I mean, I said, so, but do you have any robotics platform, or what is the planning here, right? So, are the students from the schools, or the schools have any robots, or is it what is, yeah. Yeah, so I think that is the key part, right? So of course, organization, the competition, but what about the background of the students? Do they know coding, and do they know Python? I mean, as I said, this is something that you need to make sure that they know first, right? So what kind of students? How old are they?
They under 19
Okay.
high school student. They usually can programming using C++.
Mm.
Maybe some person can in Python too.
Okay, okay, okay. And and the students, they are learning only robotics, right, at your school. Am I correct?
In their school, they're learning everything, but in this event or just in my school, they just learning robotic. But in their school, they're uh, academic school, they learn everything, not
Yes,
just robot.
yes, yes. No, okay. I'm just asking. So are you? So the academy that you are running is a school that specializes in providing like enrichment class on robotics, right? It's something extra, right? So
Yes,
it's not. Yes,
yes.
yes. Okay, okay. So yeah, I mean, yes, yeah, yes. And so is it something that's totally new in your offering, or are you already teaching the students navigation, vision, manipulation, speech recognition?
For my student, is totally new.
Mm.
They usually just a drone, underwater robot, or just rescue soccer.
Ah, okay.
Yes,
But there's
robot
no
like that.
AI, right?
Yeah. Not yet.
Yeah. Okay. Okay. So yeah, I mean, I said the there are a few things that you need to consider now. Like first of all, how do you start the whole planning, right? So, for example, we need to think about the hardware, right? So, do you need to have a robotics platform like this, or you want to build yourself? Well, that is also possible, but you need to know how to do that and the cost that comes with it. Or if you can think of as well, this is another product that I also can recommend to you. Is probably a bit cheaper and smaller, and if especially if you have a big group of students, that is also suitable for them, even for home-based learning, right? So they don't need to gather
Yes.
due to the COVID-19. They can actually learn from home as well. So if you equip them with such unit, they can plug into the computer, and then you can yes, get started in learning the basics in vision and speech, right, without having the full robot. And once they are ready, then you can select students to form a group, and then they can then join the competition with the Jupyter robot, for example.
Yes.
Mm.
We will use your platform for accelerate AI learning in Indonesia.
Mm, mm. I mean, of course, then it will will come to the part about financing as well. I'm happy to make you a quotation, or if you need, but roughly, for example, but I say it's beyond the sale of hardware. Do you need a workshop, for example? Can we provide you classes? Likelihood is not going to be physical classes in Surabaya. Probably until the pandemic is over, we need to do it virtually, right, online. That we can,
Okay.
if you purchase the robot, we can ship the robot to you, and then we can do the training to your teachers, to your instructors online as well. So that's also possible.
Yes, I think that is possible.
Yeah.
If they need more support,
Yeah.
I can go any city in Indonesia if you can go to Indonesia.
Yes, if we can go, I would be of course love to do a physical training, but at least at this moment, I think it's pretty hard. I mean, with the quarantine, with the
Yes.
situation, yeah. But just just yeah, we do both on site. So let me show you some. So if it is a physical shop, so it looks like this, right? So I used to do that. We used to do it in Malaysia. So as you can see, it's a classroom, and then we will have the robot, and then the teachers, the instructor, the participants will work together hands-on with the robot, and then we have a theory session, etc. And then, but if it's an online workshop, we can do that as well. We did that with a Mexico university, that we do it completely online, right? During the pandemic time with the mask on. Once we delivered the robot to them, then you can straight away do this, like what I'm doing to you now, virtually, right? It's a new experience. It could be a bit cost saving because I don't need to travel. There's no accommodation cost. There's no worry about COVID-19 as well. So I think so. This is also possible. So ultimately, it depends on the timeline and the planning from your side, right? So when do you want this to happen? Okay.
Okay.
Yeah. So, any other questions from any other colleagues here? Yeah, on the Jupyter robot, on the IO.
Maybe Rizky, do you want to ask something? or
Uh,
Pak Teguh?
yeah. Yeah. Okay. Let me introduce myself. I'm Rizky. Basically, I'm a university student, and then yeah,
Ah,
I have some basic knowledge on robotics, and yeah, I have an experience playing with ROS actually. And
ah,
then maybe I'm interested in your platform, Mr. Jerry.
mm,
How about the I mean, can we like put another module to your platform, or is it already settled? And yeah, the feature just as it is, or like
no,
for example, if we buy your platform and we
that
want to put another sensor, something like that, is it?
definitely.
Mhm,
It is possible because as I say, it's an open platform. So you
mhm.
are free to add your sensors, you remove this or etc. But you need to know how to do it.
Yeah, yeah, sure.
This is the difficult part. But from the technical perspective, it's positive.
Mhm,
It's possible. As I say, because we are maintaining an open platform. I think this is
mhm,
a very big advantage if you compare
mhm,
to many robots in the market. They are a closed proprietary systems. Like so, it's like whatever you do is you cannot really modify the system. But that is
mhm,
not good. I mean, so that's why the Jupiter robot it doesn't look like a very fancy robot, but it's for you to change if you want to change, right? If you want to modify, you want to add in sensors, yes, that is theoretically possible, but you need to know how to do it. Yeah.
mhm. Yeah, as long as the platform is have an access for us to explore the system, the hardware, yeah,
Yes.
it will be very good. Mhm,
Yes, definitely, and that is actually the whole purpose of this, right? Is that
mhm.
we
I understand.
we put together the hardware system so that you
Mhm,
don't need to buy it separately and you don't think about how you integrate, but you can straight away concentrate on learning how to do the programming, right? How you program
mhm,
the camera system, the navigation system. As I said, everything is based on ROS, is open source. You can find a lot of information as well online.
mhm.
That's the idea,
Yeah,
right? You need to learn
yeah.
from us only. You can find all information on your own. For example, these are
Mhm,
like Kinect sensor. So there's an Astra vision sensor. You can find online
mhm.
information. Turtlebot, which is the base, you can also find information online. Okay.
Yeah, sure.
Mm,
And yeah, one other question. You are
yes.
talking about your workshop and training
Yes.
program that you have. Based on your experience, usually how long does it take to give a student, maybe high school student, to learn about AI and machine learning?
That is a good question,
Mhm,
but it's very difficult to answer you because I
mhm.
think we need to have a change of mindset when you are learning this. It's very different from, let's say, you learn like the Lego robots or
Yeah,
which
sure.
you can finish in 2 days, right? But
Mhm,
now we
yeah.
are talking about development, so that's beyond the workshop. We students need to have the time. They need to have
Mhm,
time to invest in developing solutions, and they need to
yeah.
have to try out. So this is something that you can learn in. So as I walk you through the course, right?
Mhm,
So I thought so. These are the course, right? So these are like the course material. You can learn this
yeah.
in 2 days, in one weekend, in 1 week, or even one semester. So it really depends on how deep you want to go. So that's why I say we would usually recommend, let's say, like we will train the trainer, right? So, for example, if
Mhm,
UP has any instructors at the academy, that's probably better because also probably due to the language, right? You want to translate to Bahasa,
yeah.
then
Mhm,
probably it's better for you to teach your student. But we
yeah.
can give you an overview of this, like let's say in 2 days, 3 days, or 15 hours, 18 hours. So it depends on how much you need as an introduction. And then we tell you where you can find more information. We tell you where you can find more examples. And after that, it's up to you, right? So it's really we don't hope that we will teach your students forever. We hope that we can probably train your teachers, and then you will be then thinking how you want to spread this in Surabaya, even to the whole of Indonesia, right? So that's
Mhm,
the whole idea here is that we cannot be everywhere. We are like a solution provider. We provide you the solution, but then you plan how you want to develop this further. So, but what I can tell you, what I can share with you is that it is in. I just want to set the expectation right. That is to do not expect this to be easy. If you have experience in ROS, you know, ROS is already very difficult. Now we want to use ROS, and we don't actually teach all the ROS itself. We only teach the basics in ROS so that you can actually use this for the development. And the ROS itself is actually a 2 weeks course, right? And even that you need projects. And it's very difficult as well. So again, our objective is make things that are difficult at least a bit more easier for you to get started. Okay, because last time it's very difficult to even get started. So you need to invest a lot of money, you need to spend a lot of time, and we provide you these structures, right? Whether from hardware, whether from the software, and as well for the training. So you have everything ready for you. You just need to dedicate time. So as such, what I would recommend generally is you don't want to target very, very young students, right? I mean, logically, the older the students are, ideally, for example, first year university graduates. So these are like the ideal age that they have the motivation, they have the time, and they are not as young as like 7 years old or 10 years old. It's a bit difficult, right? So if you want to get their attention to this, then I would say is that although there's actually no limitation, so anyone who knows programming, he can learn from 7 to 17. So there's no limitation for that, because you just need to know Python is what we recommend, and that's it, right? But ideally, yes, for better technical understanding, I would say yes, you maybe want to focus on the older high school students, or even better is the first year or second year of university students, for example. Okay. Okay. Any other questions?
I think enough for myself. Maybe Yudi.
So if that's the case, Yudi, so what I will propose now is that I will try to send you a summary of our discussion in the form of a presentation deck, so that you can have all this with you as a reference. And then I will really invite you to discuss internally the planning, right? So what would you want to do? Who you want to target to, and what kind of resources, right? There's a cost involved in the robot, there's a cost for the workshop, and you want to organize competition, there's also some planning needed. So I think this, I will leave it to you. And once you align internally what you want to do, like how many robots you need, how many students are you targeting, I'm happy to make a proposal to you with a quotation on the costing and what we can provide and when we can provide, okay, whether physically or online. I mean, these are the things that I will work concretely in form of proposal once you have aligned your objective, right, internally, right? Is how big should they be? Is it a pilot? Is it a test? Or you want to do it for 5 students, for 100 students? So these are the scope of the project that needs to be decided. And then I hope that I will give you this presentation deck that you can use as a reference. And after that, I'm happy to catch up in a week or two with any other of your colleagues to discuss this in details as well. Okay?
Okay.